Hello, academic stars around the globe. Welcome to Caltex Academy SME. My name is Julius and thank you for coming along. Today on our board we are looking at Introduction to Trigonometry, and this is the first video of this series. So I advise you to watch this video from beginning up to the end and follow in for the next upcoming video in that order, so that you get all what we're going to discuss for you in that sequence. So what are we expecting to learn today? We have two objectives. One is to know basic angles, and then also we need to understand what trigonometry is in terms of right angle, triangle. With all this said, let us dive in to the video. Now you can see from here we have our small heading that says right angle, triangle. So let's draw together this right angle triangle and see how it looks like. So if I've gotten some line here, and I have this drawn, and perhaps I'll also draw another one here, and I'm trying to make a right angle triangle. So this is a drawing of right angle triangle, and also angle 90 here. We can name these parts of the triangle as A, B, and C. So you can see angle C is at 90 degrees, and this angle, let us call it as theta. Now from here, in our objectives number 1, we need to learn trigonometry related to right angle triangle. So when you look at this triangle ABC, you realize that there are 3 different sides in the triangle, and also the 3 angles. We have this angle at A, angle at B, and angle at C. And right angle, always angle at C is 90 degrees, or you can use any letter here, it doesn't matter. So for our case here, we have this angle, and we need to name this triangle side. So firstly, we need to look at the angle given for us. In most cases, one of the angles is indicated. So the line opposite to this angle here, maybe I can use some highlighter around to show that line. When you move in that direction, we realize that we have some line here, and this line BC is always opposite. So you can write there opposite. Now next is this line also opposite to C, that is our AB, and this one is always hypotenuse. And lastly, when you look at this line AC, that is adjacent to each of these angles, where the 90 is and the angle given for us here is, that becomes our adjacent. Now these are the 3 sides of this right angle triangle that we have to mark, and you should be able to identify very well. Like for instance, we can tweak this right angle triangle and it looks something like this. Perhaps we can make the triangle to look like that. Then another also here, this time let me make it narrow, and this will be my right angle, though it's not really all that accurate, but you get the idea. We can use the dotted line here, and I have that to represent my 90 degrees. But this time around, I am using from this side here my alpha, since I've used theta here, then use alpha for this. And perhaps I might call this one as P, Q, and R. And remember, the letters are always represented by capital letters. So capital letter represent the angle. In some cases, I can say A, B, and C, meaning the angle at B is what is represented by these 3 letters. And in other books, you will find this hat representing an angle. So some books use it without the hat. So any of the 2 choices are all welcome. So from here, what is very important is for you to be able to recognize that, okay, the skill that we have learned to identify these sides is we go to the angle given for us, then we look straight to this one, and that becomes our opposite. Now this time I'm going to select 3 letters to represent them, and we come to where the 90 is, and then we look at also straight the line opposite to it, and we hold the same hypotenuse, and Lastly, where the angle is to the 90 is our adjacent ADJ. And if we are able to organize in that form, then trigonometry will not be a problem for you. Now, the next one here, let us move on and take a look at the trig ratios. So what are these trig ratios? We have three basic trigonometry verses that will be starting with. Then we keep on adding other complex ones as we continue with our series. So let's move on and take a look at the first trig ratio from our option A. Maybe I can name this one to be our A, diagram A, and diagram B. So this one is given by sine. So sine of an angle, we normally represent it using three letters. So for our case here, is theta is given by the opposite, and opposite we can abbreviate it to three letters over hypotenuse. So hypotenuse is h, y, p. So that is the first ratio we can use. And again, we can shorten this one here to even O and H, where we say sine of the angle theta is given by our opposite O over hypotenuse H. So next, we can move on to the next one here. The second trig ratio that we also need to learn is cosine. So cosine of the same angle here, theta, is always given by adjacent over hypotenuse. So we can also write the same way, adjacent over hypotenuse. Now from here, you can see that the first ratio here and the second ratio, they both have denominators of what? Of hypotenuse. So we can also shorten up here and we have cosine of second angle theta is given by the adjacent. This is A, and hypotenuse capital H. So let's go to the third basic one here, and that is tangent. So we have tangent of any angle theta is given by opposite over adjacent. So when you study this carefully, you realize that tangent looks like we are dividing the numerator of the first trig ratio with the numerator of the second trig ratio. So let me first set it up here, and we have tangent of any angle theta is given by O over H. So you can see the tangent O is here and then A is here. Sorry, this one is an A. Now for that, mainly we can also combine to make tangent as another important definition. That tangent is also given by sine of the same angle theta divided by the cosine of the same angle theta. Now, if you need to print out how this one comes about, divide the two together and realize that you get something exactly like here. I think let's say practically they're doing it. Now, when we divide, okay, yeah, you just said tangent of an angle theta is given by the result of dividing the sine as well as given it here. And sine is the same as opposite over hypotenuse, and we're dividing this by cosine, and cosine here is adjacent over hypotenuse. So this division sign, you can make it as multiplication and interchange the numerator and denominator of our second term here. So let's get more space and we'll do that, meaning the tangent of that angle theta is the same as we maintain this opposite over hypotenuse, and we multiply this by hypotenuse divided by adjacent. So from here we can see that hypotenuse is common, we can cancel it out, and therefore our tangent of that angle theta is given by the remaining part here, which is opposite over adjacent. So this becomes what we have just gotten earlier on here is the same thing. Now these are basic trigonometric classes that we are supposed to know. And the first objective of our lesson is achieved. So let's move on to the second objective, where we shall look at how to use our calculator to make simple calculation of sine, cosine, and tangent of common angles. Yeah, so in this example, we have a question that says, use a calculator to compute the following. The first part here is sine of 30. How do you calculate sine of 30? So for that case, I don't know which type of calculator you're using, but for me, I'm using Casio FX991ES Plus. So this is the calculator I'm gonna use, and you also follow along with the type of calculator you're using there. So I think this is okay. I hope you're able to see it well. So let's go on and see how we can calculate the first one here by bringing it outside. Now, maybe let me push it somewhere near here and see sine of any angle 30 degrees from a calculator is given by, so you can punch this into a calculator and we look at where sine is. So here is my sine. I press sine and you'll see that a bracket is always created here automatically. So let's enter in 30 and don't worry this degree, the calculator knows it. So what we do is to close up this bracket. Even if you don't close, the answer will still come right. But I think it's a good practice to always open and close a bracket. So let's go on and see the answer. So our answer is a half. So my calculator will give me option of answers in fractional form, but other calculators can also give you in decimal. Now, if you want to see the decimal answer, you will come to this button, click on SD. So after pressing, it will convert it into decimal. And again, there are different countries with different way of writing things. Other countries use a dot to represent a decimal point, and some countries are using comma to represent a decimal point. Which country are you watching from? Tell us in the comment section. And what notation are you using? Is it a dot or a comma? So you can also tell us in the comment section. So this is our answer. We can put it down 0, and it's good also to give to 3 decimal places. So this answer here becomes 0.5 and 2 zeros after. Translate that to 3 decimal places. And our first question here is done. Let's move on to the next one here. And that one is cosine of 47 degrees. What is the result for this? So go ahead and pause the video, press from your calculator and tell us the answer. Okay, let's move together now and see. So I can clear off if this AC is to cancel everything. Now for that case, the next we can do here is to identify where cos is. So cosine is this button here, then we can press and we enter also our value. We have 4 and 7 and also close our bracket. The result is here. Now we have many decimal places. So to easy your work so that you have your answers consistent to 3 decimal places, you can go ahead and run the calculator to fix number of decimal places like 3, like 2, depending on which one you are good at. So let's do that in this calculator. For us to do that, we need to identify this button called back, and we need to do some setup here. The setup looks the same in this color, something like brown color. So you can shift it, second function, and we go to that, and you can see fix is on 6. So let's press 6, and the computer will ask us which number of decimal places do you want to fix your calculator to from 0 up to 9. These are the counting numbers 0, 1, 2, 3, 4 up to 9. So for our case, we wanted 3 number of decimal places. So we can come here and punch 3 to get our answer rounded to 3 decimal places. Do you have challenges doing your calculation? If you do, please let me know and the type of calculator you use. I might make a video on how you can use that calculator. Okay, so let's move on. Our answer is 0.682. And let's move on to the next one here, and that is tangent of 53 degrees. So we can move on and also get our calculator and we enter everything here. For me, it's always good. I just need to figure off and identify where tangent is. So that is my tangent, and I enter that angle 53, closing my bracket and give equal sign. The answer comes automatically to three decimal places, and I have 1.327. So we have here 1.327. Now let's move on to the next one here, and that is tangent Q and 78 degrees. So this one is beginning to look a little bit strange. Now for you to do this right, what we have to do is to write this one that looks exactly like the first three, and this one is a power, and that one is tangent. So let's create a bracket here, and we have tan of the angle 78 degrees, then we will cube it. So this is how it's written in trigonometry, but for it to be correct answer from your calculator, you have to transform it to be like this one. So let's move on and grab our calculator and see how we also do this calculation. Now let's create our first bracket here, and then we move on and write our tangent, and we also enter our value 78. We close this bracket that is inside here for the angle, and then now we generate another bracket for the exponent. And for my calculator here, I have two options here of either using this button for a power or exponent, or we can use another button. It is somewhere there. We need to get some second function in order for us to get it. This is for Q. Since it is Q here, we have that play for Q. I don't think whether you can see it well. Now let me try to expand this calculator a little bit for you to be able to see how this one looks like. So if I zoom the calculator to play, that is what I'm talking about. X is power 3. So if we need to use that, you can press like that, and we press here, X is power 3 is, and you'll see keep appearing here. That gives us our answer. Or what you can do is to use the other button. Now maybe let me erase this one here. What we can do, we can press this button, and you'll be having a space created, and enter whatever number you have here. For our case, it's 3. You can enter 3, and we are back to our answer. So when we punch this, that is the result of our calculation, and that is 104.104.130. So that is the answer for the part D here. This is that one. Think let's mark with our corresponding colors that we use. Also, I think this one is the same color. We can go on and take the other one here, that is E. And our E, maybe let me use this arrow so that you don't confuse yourself. So for E, we have 3 before it, and we have sine, also squared of an angle that is 3 degrees. Now let's write this the same way. We have done here because we have an exponent here. So we'll have 3, create this bracket, and sine of the angle 3 degrees, and this time it is squared. So let's get into our calculator, and we punch this starting with 3, and with a bracket, we look at sine, we enter the angle 33, we close the bracket of the angle, then we create another bracket, we raise the power of 2, and that is the second function. After all, we have some button here for exponent 2. You can press this directly, and you get your 2 written there by default. So when you press this button equal sign, we get our results here, and that is 0.890. So let's put it also down here, 0.890. So that is the answer for this. And finally, let's take a look at the last one, and that is this one here, where we have some fraction, and that is 5 over 7. That means cosine of an angle 85 raised to power 4. So for that, we can recopy such that our working becomes also quite easier from our calculator. So 5 over 7, we can hit a bracket and we write our cosine of angle 85, and this one, we close this bracket up and we raise this to the power of 4. Now our answer will be somewhere here. Again, grabbing our calculator. So from here, I have some button for fraction, which is right away from here. If you don't have this, there's some calculators with the button that looks like this one. They will have something like maybe A, or maybe let me expand it bigger so that you see clearly. If this is this type, you can also let us know. And how you can use it, we have something like A, comma, B, comma, C. Or others will look like A is somehow bigger, we have B over C, something like that. So that is the fraction button in that type of calculator. Maybe you're having it, I don't know. Mine is having a button with fraction directly. So let's take a look and see how we can also work out this. So you can press this. You have two choices, either to press this one first before you press the first number, or you can first write the first number before you press this one. It works all the same way. Like if I have 5, then I press this button. Of course, the 5 definitely becomes the numerator and it goes down denominator here, and then press our 7. Then you have to move these cursor keys. So we're moving to the right. So we press this one and we take our cursor blinking to the right. Now we identify our course, then we create the angle 80. I think if we go to that thing, that is the bracket because we have some square here. Let's go ahead and create that bracket first before coming to cos. And we have 85, we close that for the angle, and then create for the bracket. That means the answer will go from here, we multiply with our fraction here. But remember, it is raised to power 4, and our calculator is trying to cover it. Let's move it somewhere a little bit. Here is so fine, we are able to see. So we can press this button to create a space for 4, and this is our 4 we found equal to, and that is our result. Meaning our result is somehow smaller. For us to be able to see it, we need to increase the number of decimal places here. Or we can write it scientific notation also as well. Now let's go to sit and we press this button to set up. We come to 6 for the fixing and we increase the number of decimal places. Maybe let me say 5, and you can see that we have this digit here, 4 zeros before the number 4. So that becomes our answer as 0.00004. So this is how we use calculator for calculating ordinary numbers, just like what I've just said here. If this video is interesting, please give it a like, share with friends, and subscribe to the channel. And remember, in our next video, we will be looking at special angles that do not require a calculator. For somewhere, you can be asked not to use a calculator and then simplify something, and that is exactly the video that we are looking at. So please don't dare to miss that video because it is really going to be very interesting. So look at ways of making it simpler for you. See you in that video. Peace out.